Hey everyone, in this video we're going to learn about box plots, which is another way to represent data. To start, determine the median of the following set of numbers, which are 2, 5, 5, 6, 7, 7, 8, 10, 11, 14. So we have a set of 10 numbers. They're listed from least to greatest, so we don't have any rearranging to do. Then the median is going to be between the 5th and the 6th number in our set. So 1, 2, 3, 4, 5, 6. So right in between those two numbers. That will be our median. And the average of 7 and 7 will be 7. So the median of this data set is 7. Now suppose we didn't want to split the data into the lower 50% and the upper 50%. What if we want to split it into 4 equal groups? Well, we can do that by taking half of a half. We can look at the left side of the median. That's half of this set of numbers, and there are 5 there. And we want to split that in half. So the middle number, which in this case is 5, would split it into 2 and 2, which are equal groups. We can do the same thing on the right side of the median, 5 numbers. 1 in the middle would split it in half, 2 numbers and 2 numbers. So now we have 4 equal groups. 2 numbers here, 2 numbers here, 2 and 2. Notice the numbers that we circled do not get included in any of the groups. They were part of the set of numbers, but they act as the dividers, splitting the numbers into those equal groups. We have a special name for these numbers. In this case, the 5, the 7, and the 10. They're called quartiles, and they are the values that divide a list of numbers into 4 equal groups, or quarters. And quartiles are important because they're going to help us create a box plot, which we can see below. Here is the box plot to represent the data that we were just working with. Let's look at a few things we should notice. 2 is where the box plot starts. Well, 2 is the lowest value in our set. So 2 is the minimum. Going to the other side, 14 was the largest number in the set, so 14 is the maximum. 7 was the median. That split the data into half. And then we had the 5 and the 10. 5 split the lower 50% in half, and 10 split the upper 50% in half. So these are quartiles. 5 is the first quartile. So the first quartile. 10 is the third quartile. Now you may be thinking, where is the second quartile? But that's the median. We could call the median the second quartile. We typically call it the median, but we could call it the second quartile as well. Now, we abbreviate these. The first quartile, we're going to label as Q1 with a subscript of 1. The median, that will be Q2. I don't want parentheses around that. Let's just write Q1. And then the third quartile, that's going to be Q3. And those are the 3 numbers that split a data set into 4 equal groups, or quarters. Right, now if we take all 5 of these values, the minimum, the first quartile, the median, the third quartile, and the maximum, they are the 5 numbers that we are going to need to create our own box plot. And we'll look at that later in the video. Now, if these numbers divide the data set into 4 equal parts, that means that on this part of the box plot, there is 25% of the data. In this part of the box plot, there is 25% of the data. In this part, there's 25%. And on this part, there is 25%. Okay, so each part of the box plot represents 25% of the data, or a quarter of the data. This is important because they typically ask how much data is in the whole box, right? And our answer would be 50%. How much data is from the minimum to the third quartile? That would be 75% of the data, right? So knowing how the data is distributed in a box plot is really helpful for us. Now there's another piece of information that we can get from a box plot, and that's the interquartile range, abbreviated as the IQR. And it's a measure of spread that is found by subtracting the value of quartile 1 from the value of quartile 3. And mathematically, we can see it here as the IQR equals Q3 minus Q1. So in the box plot above, which is based on that first data set, the IQR is the third quartile, which is 10, minus the first quartile, which is 5, and that is equal to 5. Now, what does that mean? That means that 50% of the data is within 5 numbers of each other. Right? The largest gap would be from the first quartile to the third quartile, and that's a distance of 5 away. That's why we call it a measure of spread. We know how close together 50% of the data is. So again, walking through it, box plot starts at the minimum, the box starts at the first quartile, ends at the third quartile, split by the median, and then it continues all the way to the maximum. The following box plot represents the number of concerts that students in Mr. Jones's math class have attended in the past year. Okay, so let's just look at this box plot first. So 0 is the minimum, 3 is the first quartile. We could label this, right? So min, 3 is that quartile 1, 4 is the median, 8 is quartile 3, and 10 is the maximum. Within each part of the box plot, there's 25% of the data, right? So right here, 25% of the students fall into this range. 25% going to be tight squeeze there, 25%'s there, 25%'s here, and 25%'s here. So let's use this box plot to answer the questions that follow. What is the median of the data set? So that is 4. What is the range of the number of concerts students have attended? So the range, not the interquartile range, just the normal range, is the max minus the min. So this is 10 minus 0, which is 10. What percent of students went to at least 8 concerts? Okay, so at least 8 concerts would be from here all the way to the maximum, which is this part of the box plot, which we've already identified is 25% of the students. So, answer that question, 25%. Same box plot. What percent of students attended between 3 and 8 concerts? Okay, so between 3 and 8, that's between the first quartile and the third quartile. So that's going to be 25% in this part, 25% in this part. So that is 50%. Let's fix that 0. 50% of the students have attended between 3 and 8 concerts. What is the interquartile range? So interquartile range is Q3, and I'll write this out, Q3, third quartile minus the first quartile. So that's 8 minus 3, which is 5. If there are 24 students in the class, how many attended at most 3 concerts? Okay, so at most would be from 0 to 3, which we identified as 25% of the data. So 25% of the 24 students. So how are we going to compute that mathematically? We're going to convert the percentage to a decimal, so 0.25 times 24. We can think of 0.25 as 1/4 times 24, that would be 6. So there are 6 students that attended at most 3 concerts. When creating a box plot, we need to find the 5-number summary. That's what we call the numbers that we labeled on the box plot earlier, the 5-number summary. So if you ever see a question that says, give me the 5-number summary, we're looking for the minimum, the first quartile, the median, the third quartile, and the maximum. Those are the 5 that we need to create that box plot. So create a box plot to represent the number of chin-ups that can be done by 10 students. So we're starting off nice because they've already listed it from least to greatest. So let's write out our 5-number summary. So we need the min, we need the max, we need the median, we need quartile 1 and quartile 3. I could have written those in order as well, but the min and max are easy to find. The minimum, that's 1. The max is 10. The median, so we have 10 students, so right between the 5th and the 6th, 1, 2, 3, 4, 5, so right here, that's going to be our median. So the average of 3 and 4 is 3.5. So our median is 3.5. Quartile 1, so we're going to split the lower half in half. So right there, that's quartile 1. And then quartile 3 is right there. So quartile 1 is 2, quartile 3 is 5. Okay, so they've given us a number line so that we can space it out well. It's going to be important when we start to analyze these later in the unit that we have a well spaced out interval. Okay, so minimum is 1. Okay, so we start this at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could have started at 0 as well. All right, so minimum, put a dot there. Then quartile 1 is 2. Okay, so I'll draw one side of the box. Quartile 3 is 5. Okay, I like to jump to quartile 3 just so I can create that box. Then the median splits it, so at 3.5, so that's right between 3 and 4. There's our median. And then our maximum is 10. So we connect with a line from the min to one side of the box. We go from the other side of the box to the maximum. And there we have our box plot. They didn't ask, but the IQR here, just to practice with that computation, well, that would be quartile 3 minus quartile 1. So 5 minus 2 is 3. That's a terrible 3. Let's fix that. And again, 25% of the data here, and we see that there's 2. 25% of the data here, 25%, 25%. We don't count quartile 1, quartile 3, and the median in that computation because they're the dividers. Create a box plot to represent the number of hours 15 clowns spent practicing juggling the past week. Right away, looking at the list of numbers, it does not go from least to greatest. So the first thing that we have to do is put this list of numbers in numerical order, from least to greatest. So looking at the numbers, the lowest number I see is 8. So we'll start at 8. And we'll cross out just to make sure we don't miss any. And then there's another 8 at the end. 9, we have a 9 there. 10, right here. Is there any more 10s? No. 11. And no more 11s. 12. And there's another 12 there. 13, I don't see any. 14, right here. 15, no more. 16, 17, 18, 19, 20, 21, 22, and the last number, 25. Now, just to double check, let's make sure we do have 15 numbers in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Nothing would be worse than missing a number. Okay, so we'll write it in order this time. We'll go minimum, quartile 1, median, quartile 3, and the maximum. So the minimum number in our list is 8. Maximum is 25. The median, we have 15 clowns represented here, 15 numbers. So the 8th is the middle. 1, 2, 3, 4, 5, 6, 7, 8. So 14. And then we're going to split the lower 50% in half with the first quartile. So there's 7 numbers. The middle would be the 4th. So that's 10. And quartile 3, that would be the middle of the upper 50%, these 7 numbers, which is 20. So we have the 5-number summary that we need to create a box plot. We have a number line given to us, so we have to label it. So we go 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so now we're going to put a point for the minimum. Then let's create our box. So quartile 1 is the left side. Quartile 3 is the right side. Okay, so there we have our box. The median at 14. Okay, so that goes right there. The maximum is at 25. So then we can extend the line from the box to the maximum and to the minimum. So there we have our box plot. 25% of the data here, 25%, 25%, 25% based on this box plot. The IQR in this case is 20 minus 10, so an interquartile range of 10. And again, that means that 50% of the data is within 10 hours, in this case, of each other, right? Because the widest gap would be from the first quartile to the third quartile. Samantha received the following scores on her last 9 social studies tests: 96, 90, 60, 92, 98, 94, 88, 92, 96. Do any of the scores seem unusual compared to the other scores? So I would say that 60 jumps out as being unusual. Her grades seem pretty good except for that single score. Okay, so the score of 60 seems unusual. Now we have a way mathematically to define that. It's called an outlier. And an outlier is any data point that is more than 1.5 times the interquartile range below the first quartile or above the third quartile. Okay, so we have 2 different equations to find an outlier. Here's one of them. Quartile 1 minus 1.5 times the interquartile range. Or, here's the other, quartile 3 plus 1.5 times the interquartile range. Hey, so if we want to know mathematically if something looks weird, unusual, well, this is how we're going to calculate a number to know for sure. So here are the same test scores. Is the score of 60 from Samantha's test scores considered an outlier? So just like in the last problem, the first thing we have to do is list the scores from least to greatest. Okay, so 60 is where we're going to start. And then 88, 89, I don't see any, 90, yeah. 91, no, 92, and another 92. 93, no. 94, yes. 96, 96, so there's 2 96s. And then a 98. Let's just make sure we have the right number of test scores. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Okay, so in order to figure out the outlier computation, we need to find first quartile, the third quartile, and the interquartile range. So we'll start by finding the median. So 9, that would be in the middle of the 5th test score. So that's right here. That's our median. Now we have 4 scores to the left of the median. So splitting those in half would be right here. Okay, so that's going to be quartile 1. And that's the average of 88 and 90, which is an 89. Okay, so that's quartile 1. Similar, here we have 4 scores. Right in the middle is the average of 96 and 96, which would be 96. And that's quartile 3. Okay, so just to organize our work, quartile 1 is 89. Quartile 3 is 96. So then the interquartile range, that's quartile 3 minus quartile 1, which is 7. So we have 2 different computations to figure out the scores to define an outlier. Okay, so first thing, because for both of them we have to take 1.5 times it, let's do 1.5 times the IQR. Let's fix that Q. IQR. So that's 1.5 times 7, which is going to be 10.5. Okay, so to figure out the test score that she would have to be below for it to be an outlier, that's going to be quartile 1 minus 1.5 times the IQR. Okay, so that's going to be 89 minus, we already did that out, that's 10.5. So that would be a 78.5. And then to figure out the score, she would have to be above for it to be an outlier. Well, that would be quartile 3 plus 1.5 times the interquartile range. So quartile 3 is 96, and then plus 10.5, and that would be 106.5. So is the score of 60 considered an outlier? Well, so let's just, you have to score less than this or greater than this. Well, is 60 less than 78.5? It is. So 60 is an outlier. Now, we do have ways to represent that on a box plot, but we're not going to go that far. That's something that you would learn in a statistics course. But essentially, what are we doing with this computation? We're taking the sides of the box in the box plot, and we're taking the interquartile range and going to the left and to the right of the box to figure out if something is outside of that range. If it is, we define it mathematically as an outlier. Okay, so we covered a lot, a little bit of new vocabulary as well, but the main focus was the box plot and the idea of the 5-number summary. That is the minimum, quartile 1, median, quartile 3, and the maximum. Those 5 numbers help us create a box plot. We also define the interquartile range, which we can see here is useful in determining whether a data point is an outlier. And then we also emphasize the fact that 25% of the data was in each part of the box plot, right? And a lot of times they ask what percentage is between the first quartile and the third quartile. And as long as we know there's 25% in each part, those are easy questions to answer. So now you need to go practice with the box plot, both interpreting and creating. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.